Hey everybody, this is Mr. Munson, and we are going to start concept number 3 in this G7 unit right triangles. And so unit 3, we're going to be dealing with trig functions. And the really cool thing about trig functions is that it is the first equations that we're going to have this year where we actually do mix angle measurements with the lengths of sides. And all year I've been fighting with many of the students who keep on adding up the sides to make them equal to 180 degrees, and I tell them, hey, you can't add sides to make it equal degrees and things like that, that you can't mix them in the same equation, degrees and lengths. But guess what? I lied to you. In concept number 3, 7.3 here, that's exactly what we're going to do. Let's get started. So we're going to start off by first teaching you 3 new equations, okay? Now you need to know how to write left side and right side, and there's an equal sign in between it. So we have sine, cosine, and tangent, and then just after those letters will be this funny symbol. You create that symbol by just simply drawing a circle and then doing a loop like this, and it creates kind of a funny hair piece going across the top. And that's the unknown angle that we'll call theta. Now, theta is basically the unknown variable in the world of trig. So you know how you use x and y's in classic algebra equations? Well, in the world of trigonometry, we use this letter theta to take a place of an unknown angle. All right, so what we find out is the sine of theta, okay, the sine of theta is equal to a ratio between two specific sides in a triangle, depending on which angle theta is representing. So we could be talking about theta being the angle A or the angle B, but I'm here to tell you theta will never be the angle C at the right angle. Okay, it could be the letter C as long as C is over here on the acute angles, but it'll never be the right angle that we're putting into this place. So sine of theta, whatever sine means, when you apply it to whatever the angle is, it's going to be equal to the exact number of what the opposite over the hypotenuse is. So if theta happened to be the angle B that we were looking at, when I take the sine of 30 on my calculator, or sine of B on my calculator, it'll be equal to whatever the opposite side over the hypotenuse is equal to as a ratio. Now let's look at cosine. Cosine is the adjacent over the hypotenuse. So if theta happened to be B, then it would be the adjacent side, which is, in this case, CD, whatever that number would be, over the hypotenuse length. And then finally, tangent of theta is equal to the opposite over adjacent. Now, these look rather complicated, might throw you for a spin trying to remember these at first, but once you have them, you have them. Let's take a look at using these equations to apply it to a triangle. Now, in the future, we're going to be using these equations to find an unknown. Right now, we have everything there is to be known about this triangle. We have all 3 sides and, of course, all 3 angles as you look. So I just want to use this moment to kind of show you how you take pieces from a triangle and plug it into these formulas. Okay, let's pretend like we're standing at C. I'm sorry, let's say we're pretend like we're standing at A. So here I have the trig function sine of A equals opposite over hypotenuse. So that would say this, the sine, and then we take the angle and we stick it in that spot, equals opposite over hypotenuse, 6 over 10. Now let's take a look at the calculators we're working on in our classroom. Look down this row and you'll see the buttons sine, cosine, and tangent. And so we're going to take a look at those buttons. If you don't have a TI like this at home, a couple of options. First of all, most iPhones and most Android devices have a scientific calculator that a lot of times you just turn it sideways and all of a sudden you get it. You might do a real quick Google search to see if your phone has already a scientific calculator, and you'll see that it has sine, cosine, and tangent keys on it. The other option is that you can go to your app store and find a scientific calculator that probably free for you to download to your phone or whatever. But in any case, at home doing some of these problems, you're going to need to have sine, cosine, tangent functions available to you. Okay? All right, so let's go back to looking at this calculator. So Let me kind of get rid of this here real quick. Okay, so kind of getting back to our work here, this is what we had. And I want you to understand that in these equations, we're going to have an unknown. And we have all the information for this triangle. That's why we don't have an unknown down here. I just want you to show you how this equation does work. You have a left side and a right side. This ratio on this side is a ratio between sides lengths. Over here is an operation that's happening to the angle that's related to the sides we're talking about. So take a look. I'm going to, on my calculator, do the sine of 36.9. And I'm also going to go 6 divided by 10. You should see that these two numbers are the same. All right, let's first start by going to our calculator, making sure it's turned on. And every time from this point on till the end of the year, you're going to go to your calculator and go to the mode key first. Then you'll toggle down to radians and toggle over to degrees. Hit enter, and that'll put it into the degree mode. This is not, feet and inches, but it's like this. If I want to make sure I'm getting the answers that everybody else is getting, I need to all be in the same mode. You have to be in the degree mode. Okay, very good. Let's go ahead and second quit to get out of that. And I'm going to do sine of 36.9. Now I should get 6/10, which is 0.6. Okay, it's close enough. All right, so that is 6/10. So again, left side equals right side. Again, right now this equation right here doesn't give us much use. I'm just trying to show you how angles go in here, sides go in here, and these two things actually end up being equal to each other. Okay? Now let's see if you understand exactly what I'm talking about. I want you to go over and pretend like you're standing at C. I want you to go ahead and write the ratios that belong to the view from C, opposite over hypotenuse, and so on. And then come back and check your work with me. And it should be 8 over 10. Of course, later on we might want to reduce that if I was given it as an answer, but for now, let's just write it as 8 over 10. Let's go on to cosine. And for cosine, you should have 6 over 10, adjacent over hypotenuse. And then finally, for tangent of C, should be 8 over 6, opposite over adjacent. All right, put me on pause and see if you can write down that Native American girl's name that we learned about back in 7.1. It's 9 letters long. Let's see if you can get this on your own. Go. Okay, hopefully you got 9 letters. And it was so, ka, to, All right. So let's again kind of review our sine trig functions here, or our trig functions. Sine of theta equals opposite over hypotenuse, cosine of theta adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. Okay, so one of the things is just even writing it in a simpler form can help you remember it. Okay, so I've seen it written like this before. And remember, these are equations, so everything has an equal sign. What I'm getting ready to show you is just a simpler way of writing it that might help your brain wrap your head around it, right? So we have sine is equal opposite over hypotenuse, cosine opposite, or I'm sorry, adjacent over hypotenuse, and then we have, oh dear, tangent is opposite over adjacent, right? Okay, very good. Now, here's an interesting thing that you haven't maybe caught on to. This is your trig functions right here. SOHCAHTOA stands for your trig functions. If you take a look at the very first part of it, so that's sine equals opposite over hypotenuse, ka is cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So if you know how to spell SOHCAHTOA, what I would do is write that down and then use those to help you write your trig functions. All right, let's take a few moments and use those trig functions to help us find the sides of a triangle, and in just a few minutes we'll use it to find an angle. Okay, so in this right triangle, we have the 36.9, the 53.1 angles there in the acute. So I want to find x. So what I'm going to do is I'm going to write some trig functions. We really only need one trig function to find x, but I'm going to write all three of them to show you how you go about doing that. All right, so if I was standing at D, I would see that the sine of 36.9 is equal to opposite over hypotenuse. The cosine is equal to the adjacent over the hypotenuse, and then the tangent is opposite over adjacent. If you look at this equation right here, it has an unknown of y. That doesn't belong over here, but belongs over here. That's an equation that'll help me find y. This equation here is the one I want. This equation here is going to cause me trouble because it has two unknowns. Now, the more you do these kind of problems, the less of having to write all the trig functions you'll get. You start looking at the variable that you want, the piece that is known, and you ask yourself, what takes the adjacent and the hypotenuse and compares them? Well, that would be cosine. Now, the next bit of this is the artwork of solving for x. Now, I forgot my equal sign, so let's plug that in. So I have a ratio on the right-hand side. So if you know anything about me, I'm just going to turn this one into a ratio and cross multiply. I end up with x equals. Always put the number that you're multiplying times the trig function out in front, cosine of 36.9, and now I'm ready for my calculator. Now, since my calculator's been on, my mode has not changed, okay? But if you come in the next day, you always want to check that. Make sure you're not spending any time coming up with wrong answers. So now it's just a matter of plugging it in. The cosine of 36.9 times 5, as I have there, hit equals, and I've got myself 3.9984. And if it's all good with you, I'm going to go ahead and turn in x to be approximately equal to 4. All right, you go ahead and take a look at the way I solved for x there. I want you to apply that same artwork to doing sine of 36.9 equals y over 5. I want you to go ahead and do that work and solve for y. Come back and check it with me. Now, hopefully you had it exactly that. And so again, we'll go to our calculator and we'll go 5 times the sine of 36.9, get an equal, and you can see it's equal to 3. Okay, so approximately equal to 3. All right, and there you go. Now, I just want to take a few seconds to say we could have been looking from the 53-degree angle and came up with trig functions that have different angle here, different numbers across from it, and come up with the same answers. Let me just show you. Let's say I was looking at 53.1. I'm standing there at angle G. So from angle G, if I was looking for x, I would say, hey, what trig function relates that angle to this opposite and this hypotenuse? That sounds like sine. So I go sine of 53.1 equals x over 5. Do my math. And then I just simply plug this in my calculator and I get exactly the same number I did for x over here. It was 3.9 something. Okay? So either way I do it, whichever angle I'm standing at, I'll create the same x. Okay, so here's a triangle, and I just want you to see if you're getting the idea of this, okay? So I have us standing at B, and I want you to see if you can take and put in the correct numbers that go in these places, okay? Go ahead and fill in this information, then this information, and so on, okay? All right, for this one here, you should have wrote 12 over 20. On this one here, you should have 16 over 20. Let's just take a quick look. Opposite over adjacent is sine. Opposite over hypotenuse is sine. Adjacent over hypotenuse is cosine. So now we're looking at the tangent, which is opposite over adjacent. And you should have 12 over 16 there. Now let's use our trig functions to find an angle. I definitely know that there's a right angle inside this triangle, but I don't know what the angles inside are. So what I'm going to do is I'm going to write a trig function to find that out, okay? Suppose I'm looking for angle A. So standing at A, I certainly could write the equation sine of A is equal to 16 over 20, opposite over hypotenuse. Notice that my unknown in this equation is the angle A, which is exactly what I'm looking for. I could have also wrote this equation to find A. It's unknown, and I'm using adjacent over the hypotenuse, as well as this tangent equation. All three of these equations are logically true with the correct numbers. I could use either one of them to solve for A. The way I go about doing them is the same process. I'm going to use what we call the inverse trig function. All right, so the inverse of the trig function sine is what we call sine inverse, and it looks like that. For cosine, it's that one, and for tangent, it's that one. These are called inverse trig functions. You'll see how to use those as we work through trying to solve for A. See, sine is a function like square rooting is a function. When it's being applied to a letter like A, I have to get rid of it so that A is by itself. If you remember when we had a problem like this, we always applied the opposite of squaring. That would be the square root. And they cancel each other out, leaving me x equals something. And so the problem I'm having here is that A has this sign being applied to it. So I have to get rid of this. So what's the opposite of sine? Sine inverse. So here's the artwork. Let me copy it down here so you can see what I add. So I need to get rid of that sign. So I'm going to put parentheses around both sides, and I'm going to apply the trig function sine inverse. If this had said tangent here, this would have said tangent inverse, and cosine, cosine inverse. It's all the same. Now what ends up happening is I have to apply to this side as well. Very important. Do not put this sine inverse on this side of the parentheses. It is not correct and you'll lose points. I want you to make sure it's over here on the left. It gets scrunched here and it's difficult, but it's no problem. It's only going to last here for a second. So sine inverse, sine, these guys cancel each other out because they're opposite. I'm left with A all by itself, which is the unknown, equals the sine inverse, parentheses, 16 over 20. I've got my unknown by itself, so now it's time to use my calculator. To do sine inverse, I have to hit second, then sine. Now it'll give me that sine inverse. 16 divided by 20, and that will give me an angle measurement of 53.1 degrees. Okay, so I just found angle A. I could subtract it from 90 to get the remaining acute angle, or I could create another trig function to find B. I like to do that just in case I make a mistake with finding A. If I subtract it from 90 to find this other acute, and I've made a mistake here, B has no hopes of being right. So I always like to just go write another trig function, sine, cosine, tangent, and I find what that angle is using the same mark. Okay, that's it. You got 5 problems. Two of them are review. And so make sure you get these problems right so you can get full credit for watching this video. Now, if you're doing this on Edpuzzle, the answer or the places to put in your answers for these questions will follow at the very end of me scrolling through and showing each problem. Here's problem 1. Keep in mind, all I need here is the ratios. I don't need you to find any angles. I just need you to write the proper ratios that go with those problems. Number 2, I need you to find A, just like we did earlier with the trig functions to find a side. Number 3, you're finding the angle, just like we did with the inverse trig functions. Number 4, this is a range problem from chapter, I think it's actually chapter 4. Then on this one here, the last one, this is a old problem of you finding number 5, you're finding how much x is. And then for number 6, I'm asking you, and you can do some research, how many degrees is a semicircle? All right, take care. Have a good one.